University in Canada in 2011. Dr. Chen completed his undergraduate education at Tsinghua University in China, earning a Bachelor of Engineering degree in 1992. Following 10 years of industry experience, Dr. Chen obtained a Master of Science in Information Technology from Simon Fraser University in 2007. Prior to his doctoral degrees, Dr. Chen's research primarily focuses on information visualization, virtual reality, and the application of artificial intelligence in computer graphics. All right, can we, with a round of applause, can we invite him to the stage? Thank you.
All right, thank you very much, everybody. Thank you. It's really a good honor for me to talk about our work here, facing the audience from Nigeria and the large part of the world. Thank you very much. So I will generally introduce our virtual reality approach to augmented Cryo EM training, and later on we will have more details, the introduction and the tutorial from our PhD students Yumi and Jiahui. All right. So before I start, I want to show a quick video about the whole system. All right. So the virtual reality has been around for actually more than 20 years. And really the foundational promise is through a goggle, two eyes see differently on different, the same thing, but at a different angle. So in your brain, you form up a 3D immersive environment. So originally, it's certainly early years, it became expensive, so it was used on some simulation and on some training, like say medical or surgery, and now greatly used in entertainment. But also, again, due to his capability and the immersive feeling, he has go much beyond entertainment. Has been done in training, education, and many other real-world scenarios. Sorry. Well, the Cryo EM, we have already seen it. It's actually a Nobel-winning solution to help us understand the biosamples, to study the virus, let's say a lot of things. But unfortunately, on the other side, there's a lot of operation. There's a lot of devices along the whole workflow. The problem happens, it's not only about those high-end mathematics, also about hands-on operation. And the problem is we don't really have a lot of enough trainers, because you need the physical devices to train. And while training, you have to work on the devices to have hands-on operation. And apparently, those devices are very expensive, hundreds of thousands of dollars to millions of dollars. And no place can afford to have multiple of the devices on, we only have several, even United States, we only have 4 national centers could have multiple devices that can afford for training, and the capacity is really, really limited. So yeah, so what do we want to do? So apparently the VR can play a role here, which we want to reduce the cost, right? So you don't need to go to the training center. Let's say United States have 4 training centers from the West Coast to the East Coast. Even United States, you go there, you take a time and a lot of, the money. And not mention about the whole world, right? And also the equipment you use. And the other thing is all the equipment, because the high cost of the equipment, people want to use them on real production. So the training time is very limited. And then the problem again is during the training, you may break the devices. They are very dedicated scientific equipment. They are not really just a robots, just like a axe or some, the big heavy thing. They are very dedicated and complex. When you break them, nobody really have a backup for you immediately. A lot of times you have to wait from weeks to months to wait for people to come back to fix them because those are highly professional. And then it's about safety. So if you are not really proficiency on operating those devices, there's a lot of problems, hazards happening. For example, one of the ethane gas used in the thermal preparation is flammable. Or you have the liquid nitrogen, when you splash on your hand or foot or body, you got frozen, burn. And then certainly the consistency quality, because not everybody will work in the workbench all the time. You have a problem to solve, so you come to use the device, but then maybe another 3 months later, you come to this other one, because during the middle, you will have the structure, you will work on the paper, you examine all the effects. Not really, you're doing work on the bench all the time. So what can we do? VR can really help on this. And especially for all those hands-on operations, the most important is you have to do it in order to learn. And the VR, the best thing is learn by doing. About the knowledge, we have multiple different kinds of knowledge. One is called, we typically consider, let's say, the math or the science, the knowledge part as the knowledge. But on the other side, how we do things, how we use our hand, our body to work on things, that's a different kind of knowledge called procedure knowledge. It's about step by step to build something, to make something happen with your hand, with your body. And his focus is on execution. You have to work on it. It's not only you remember in your brain, but rather it's about the muscle memory. A lot of time you probably will see when you work on certain things, even for cooking, for example, right? You don't really think about much in your brain, but rather your hand will automatically process step by step and finish the work. And then we'll see also some like explicit knowledge, learn from the steps, from instruction, but also we have implicit learning that built from the practice and repetition. Through repeating things, we gradually burn those knowledge into our muscle and our brain, and then we'll unconsciously to process finish the whole step. So VR is really currently the best tool to provide students with learn by doing experience. In terms of the position, right? We are not saying that CryoVR can replace all the training. Being traditional, okay, you have from reading, from lecture and videos, and then you go to on-site. You learn from operating the real device. And during that time, you have to have a trainer to work with you. Basically, it's a one-to-one in-person training. And the challenge would be for the trainer is a very experienced user, but he had to spend the time with that one person. Because the high cost of devices, it's impossible to have massive training like say the typical lecture setting. You have the trainer stand there doing lecture and 100 people sit down there listening. This is not possible. So it's very, very expensive on training. So with CryoVR, we're trying to put it in the middle. After people have those theoretical foundations, they come to CryoVR to do something familiar with the whole procedure, familiar with all the devices, and then they can greatly reduce the on-site training because you still need to work with the real devices anyway, right? So, but we can significantly reduce the training time. And for the other, like say the reading lecture videos, Cryo EM, United States did National Institute of Health, NIH, had this fund to fund multiple teams, universities to develop those curriculum sources. One is called Cryo EM 101. In Caltech, they produce a lot of videos. There's another way to talk about series from Yale. And also they have this Cryo EDU to fund different training perspectives. There are plenty of those so-called paper reading lecture videos you can use. And the CryoVR is also part of the critical funded team that we're trying to provide you the hands-on training. The general objective for our team, for our project, is trying to give people some operational fluency. So master the sequence operations for the major devices before field training. We want them to fast track to independence, right? We want them to shorten the time with the hands-on training with one-to-one the trainer, but rather say, you already get all the things to understand, so now you can go there with 1 hour, with half an hour, right? Demonstrate your experience, then you are good to go. And later, then the next one is getting a conceptual understanding of the safety issues, all the hazards to prevent, to make people handle them carefully and effectively. Some of the user will be, primary user will be the students and postdoc researchers, basically the researchers who work in this area, especially for the grad preparation, data collection, those type. And certainly we want to give them learning, flexible learning paths instead of coming to a place, because currently those VR goggles, the devices are so cheap that people can afford them and to play in their home. And then very features, we try to enhance the user experience to make people feel they are really working in a real environment. We have several different training modes. For example, one is the tutorial mode. Basically, you work, during the time you work, there's automatically there's a guidance on the screen, basically like with video, with with audio, with those signs, with those visual hints to tell you which step you should do. And also we try to explain why you do it. And then we have those so-called free practice mode. You work on it by your own. And later on, you have this exam mode. You go through it, and then you finish the whole sequence, and the system will record and tell you which part you did wrong. And especially in this kind of critical tasks, you have to get 100% correct. So no error was allowed. The other one is fidelity. You want to make those things, make sure those things look real. So we purposely design the models and choose the platform to make sure that all the rendering of the environments are faithful to the real world. So it's fidelity with in terms of the model, in terms of the environment. And also we try to mimic the hand gesture, because whenever you use equipment devices in VR, you put on your work on the controller. But what you see from your goggle is actually the your designed correct hand gesture holding that particular device. And in our human perception system, what we see override what we feel from our hand. So let's say when we hold a tweezer, we will show the correct position, hand gesture for holding the tweezer. When we're holding a pipette, we show the correct way of holding the pipette. And unconsciously, the user will change their hand, the position to that position, to the correct position. So with this times of repetition, then the user, whenever they leave out of the VR, come to the real world, when they pick up the object, they will automatically use the right gesture to hold the device. And this is a hazard simulation. Like this part shows, the ethane gas, when you do the sample preparation, If you forgot, you have to use it to in the container. But if you forget about it, then the leaked gas, the ethane gas will cause some fire issues. Certainly in VR, you won't really feel the hurt, but the visual effect will give people a very deep impression. They will remember that, oh, this will happen if they don't do it correctly. And we try to improve all the different kinds of UX, for example, the details of the equipment. And also we try, like, for example, okay, a lot of time, the first time user, they come in, they don't really know the name of all the different devices. So we can turn it on and off to show the device the name. And also, let's say the right hand gesture. And just last year, a couple months ago, the VR, the software development toolkit, released a library to support bare hand operation recognition. Basically, you don't really need to use the controller anymore. So with that, we found it's actually give people a better experience, because now what your hand is doing will 100% match what you see from the goggle, the hand gesture, the position. So we tried that. And the good thing about it is, in our system, we designed to say, when you ever go to reach a device, your hand gesture will go to be a preparation mode. Although you don't really know, but unconsciously, because you see it, your hand will automatically follow the step. And also in the later on, when you really grab the object, because what you see in the right gesture, right position, the way you're holding the object, then your hand will automatically go with that. So with this, again, we reinforce the muscle memory or fine motor skills to make sure that people can use those devices in the right way. Here are some very, the basic hardware. For example, Oculus Quest, the price now is about $400 or $500 per set. HTC Vive is another brand. It's also kind of in the similar range, several $100 range. So not very expensive. Comparing, especially when we work on those biostructure training, very expensive training, those devices are relatively very cheap. So it's very easy to set up. And later on, our graduate student, PhD student, Jiahui will help you to set it up and show you how to make them happen. So the good thing, let's say Oculus Quest, it's easy and it's wireless. But HTC Vive has a better visual quality, but they require another computer. Anyway, later on you will see it. Thank you very much. That's basically our approach, the general overview about why we do it, how we do it. But later on, the details will be demonstrated later. And I'm Victor, and our team comprised myself, Dr. Wen, and Dr. Source, and also our wonderful PhD students like Jiahui, Yomi, and Kadia, and several others from previous. Thank you very much. That's all for my talk.
Thank you very much, Professor Victor Chen, for that interesting presentation. We were able to understand more practically the VR technique. And we appreciate Professor Weng Jiang and the whole team and all the facilitators again. And they also provided us with some headsets so that we can use for this, for the practical. So we really appreciate you for all the support that you have been giving to us. We'll be taking questions now. Any questions, please, on site and online. Any questions on site, online? I cannot see any question here. All right, then. Can we just appreciate our professor again for his presentation?
Thank you very much.
All right. Our online participants, please, can you just roll in the comments? Can we just thank our professor for this presentation? So we'll be moving to the next session, which is going to be the practical session. It's going to be